Hello everyone, welcome to this session. In this session I am going to explain about the equation which is used for finding the heat transfer through plain wall or a slab. That is heat conduction equation for plain wall or a slab. We have from Fourier law of conduction, that is already this equation we have taken from the Fourier law of conduction statement, and the equation taken is the Q is equal to minus K dt by dx, where Q is the rate of heat transfer and K is the thermal conductivity of the material, A is the area normal to the heat transfer, and dt by dx is the temperature gradient in that direction. That is the change in the temperature with respect to distance for the particular slab or a wall. And rearranging this equation, we are going to get that is a Q multiplied with this dx minus Ka dt. And here that this equation whatever is there, it is holds good for this slab or a wall. When the heat is transferring in this direction, the temperature is decreasing from T1 to T2 for the length L, and that length is changing from the x1 to the x2. In the x direction, that distance we can take as this is x1 and x2. Then x2 minus of x1 will give the length L, and this is the T of x. It is a temperature function of that distance. And here integrating above equation within the limits of 1 to 2. This if you take as a 1 and this is if you take as a 2, and within this limit we have to integrate it. That is Q, that is a constant, the rate of heat transfer. The variable is a dx, integration of the dx, that is equal to minus K, a constant taken outside, and integration of dt. And this the Q whatever we can have, that is a Q x2 to x1, that is the integration we are going to have the 1 to 2 limit. Therefore x2 minus of x1 we can have x, this dx will be become cx within the limits of 1 to 2, then we can have this is x2 minus x1. Similarly this side minus Ka, and this t we are going to get this one, the integration of the dt will be t, and that is within the limit 1 to 2, then T2 minus T1 we are going to get. And this x2 minus x1 whatever is there, this is x1 and this is x2. x2 minus x1 will be the length, the Q L, and this we are going to take, there is a minus K T2 minus T1 is there. This we can write, that is a T1 minus T2 to T2, and this negative sign is taken inside, that is a Ka T1 minus T2. Then this L can be divided this side, then the Q is equal to this Ka by L, T1 minus multiplied with a T1 minus of T2. And this is the heat conduction equation for the plain wall or a slab. Whenever the heat is transferring in one direction through a wall or a slab, we are going to use this equation finding the rate of heat transfer. If you know the thermal conductivity of the material, area normal to the heat transfer, the length for which the heat is transferring, the temperature between the two surfaces of the wall. Okay, thank you for watching. If you like, share, subscribe and comment.